Welcome to my channel, and dear students and all the viewer. See, here is a problem of differential equation. So this is it is given that the if f double dash x is equal to minus f of x, okay, and f dash is equal to g of x. So another function is given that h dash is equal to f of x whole square plus g of x whole square, and it is also given that the h of 0 at 0 when x is 0 is 2, and when the function of the value of the function of h at the point x equal to 1 is 4 here. Now question is that find the solution of y equal to h of x, mainly h of x. Then the curve is, the first option here is a degree of 2 and the curve passing through the origin, and the third option is a straight line with the slope 2 and a straight line with y-intercept is minus 2. See, for solution, and here is solution. This is f double dash x is equal to minus f of x, and this is ddx of f of x minus f of x. Okay, this is double dashed. Okay, so now see, so for this curve doing plus equal to 0, let f of x equal to e to the power mx be the trial solution of y, be the trial solution. No, this is not a y, this is the trial solution of f of x. So if we differentiate of this second order, we got here m square, and this is f of x, and plus f of x equal to 0. So take common f of x, and this is here m square plus 1 equal to 0. See, it is the exponential curve. This is never be either this factor equal to 0 or this factor equal to 0, but f of x is equal to e to the power mx, which is exponential curve. So this is not never be 0. So it can be written as m square plus 1 equal to 0. So therefore from this equation we can write easily this is 0 plus minus I. From that we can write f of x is equal to e to the power 0 dot x into a into the coefficient of I here is 1, so this is cos x, and plus b into sin x. Okay, this is f of x, and this is here f of x. So f of x is equal to, again right here, f of x is equal to, we got here a into cos x plus b into sin x. Okay, now f dash x, if we differentiate f dash x, this is minus a times of sin x, and this is b times of cos x. Here also given that h dash x is equal to the square of the function f of x and square of the function g of x. Okay, so this is here f of x means this is a times of cos x and b times of sin x, a b are constant, and g of x here is this is actually given that the f of x is equal to f dash x is equal to g of x. This is here g of x. So g of x is this, so minus this is square minus a times of sin x and b times of cos x and whole square. If we simplify, a square cos square, a square sin square, we got here a square, and b square sin square plus b square cos square, take common b square, so we got here b square only, and twice a b and minus twice a b, two part are cancelled out, so we got only the constant. So let us assume this is as a c1. Okay, so h dash x is equal to c dash. So you know this is a differentiation of h of x is equal to c1 into and dx integration both sides. So you got here h of x is equal to c1x plus and c2, and given condition is that f of 0 at h of 0, so sorry, this is not f of 0, this is h of 0, and this is c times of 0 plus c2. Okay, and now and this is C2. and it is given that at a is 0, at x equal to 0, the function of h, the value here is 2 given. So you can easily say that the c2 is equal to 0. And again, at x equal to 1, the value of h, function of h is equal to, this is c times into 1 plus c2. Okay, this is c2, the value of c2, it is, okay, this is given that 4. And the value here c2 is 2 here. So if we put 2, then we got the value 4 minus 2 is 2 here. So therefore the function is here h of x, and that is c1. c1 means you got here twice x, and c2 here is 2. So see, this is your answer of h of x. See the option, a degree of curve 2 degree, which is wrong. A curve passing through the origin, which is wrong, as 2 is constant, is present here, so it is not passing to the origin. A straight line with slope 2, yes, this is option C. And the fourth option, a straight line with y-intercept is minus 2, but the y-intercept here is plus 2. So C option, your right answer. Okay, thank you for watching my video, everybody.